Hello everyone, this is a Vissim video today. This is the third episode for the same school drop-off. I have already made two videos about this. The first one used formula-based routing, the second one used attribute modification, and as I promised, this third video will use Visvap. All three videos use or basically achieve the same, just with different features or different tools. If you watch all three, you can see, or if you test basically all three, you can decide which option fits you more. And I think this is a good example to see which option has some benefits, have maybe some disadvantages, because one is easier to make, one is more complex, quicker, faster, and so on. So in this one, we are going to look at the school drop-off using Visvap. Just a quick recap, the school is located here. You have access roads, we have background traffic, we have school traffic. Background traffic is shown with black and has their own vehicle type and class. School traffic is shown with white. They are white, the vehicles, and they also have their own vehicle type and vehicle class. Vehicles will need to queue up along this road. As you can see, there are these red shoulder lanes where vehicles queue and they don't block the main line, the background traffic. When the queue reaches up here, so all vehicle needs to enter through that lane and then get here. And even if you come from here, you come here, drive along that red, and then come here. When the queue reaches up here to this detector, vehicle will start to go all the way down, U-turn into this lane to use this as an extra queuing space. We use priority rules. I described in the first video how to use them in detail. But just a quick one, so there is a priority rule here. This makes sure that the always stop intersection is kept clear. So I use three conflict markers, one covering this area, then the next one covers that area, and the third one covers just before that. And here with these, it's recommended to use only for the conflict marker with school vehicles, because like here, for example, this can go back a little bit, or this one can go back a little bit, as you can see on the other connector. So you just want to avoid that a background vehicle drives or driving on that connector can impact your priority rule. So just make sure that you use school traffic only there. And also just that you don't leave gaps. So this one goes beyond that, this one goes beyond that, and this one goes just up there. Okay, and I use the same on the other side. As you can see, these orange ones are stop signs. The next thing, I use detectors to detect end of queue. So once the queue reaches all the way back here, I use a detector. And as you can see, I have LED detectors, and these ones are short and these are very long, covering the whole route. So these two are just basically to ensure that this detector ends up queue and it is short. It is short, and that is short because when vehicles turn, and if I use long detector here, they can stay on the detector for long enough that it could trigger a rerouting request. So vehicles or Vissim could think that the queue reached the end. So, because as you can see on the right side, I say that occupancy needs to be more than 3 seconds. I use 3 seconds because that's just like, it's a tested number, it works well. So vehicles drive slowly, but they only spend on the detector like 1-2 seconds. So 3 seconds is 3 seconds is reached only in cases where the queue actually comes all the way back. And the same here. So this vehicle drives through that connector. So we just don't want this to be long enough to trigger a rerouting. But here, on the other hand, so if a vehicle is rerouted through this there, then they are going to drive along the detectors. So the occupancy will be higher. And it's also very important to note that if I list all detectors, you can see that the port number is the same for all, because this way they share the occupancy, not just the occupancy, but they share, in this case, the occupancy value across all detectors. So in this case, like all these 9 detectors act like there is just one detector. And if there is a vehicle on that one for 3 seconds, then all detector will show the same. We use this feature in Visvap many times when we have like 2 lanes, and the 2 lane can just use basically the same port number, so we don't need to check against 2 detectors the condition, just 1 port number. So on the right side you can see that the Visvap code is very simple. I just basically have a single condition where I say occupancy for detector with port number 1. So it's not detector number, it's port number 1 is more than 3 seconds. If that is true, then I set routes. I have static and partial routes as well. Static routes cover the main movements. I have specific or separated static routes for background traffic and for school traffic. So if I list static, you can see the first 2 are only for vehicle class 10. Vehicle class 10 is just background traffic. Vehicle class 70 is school traffic. So if I just show you what routes I have. So this is the one that we have static routes for school traffic. And this is the other for school traffic. As you can see, this only one takes the default route into the school. And there is no route covering that. So how do we deal with that? We deal with that by using partial routing decisions and partial routes. So if I list that, a partial route basically provides an override, like it can do like a local redistribution of that traffic. As long as they get back where they get back to the original static route, just in a route, basically you can just take a section out and you can overwrite it with a partial route. So in this case, if you come from here, you can see there is a partial vehicle routing decision. And that one has 2 routes. One route is the default. And the other one is the detour that provides more queuing space. And this gets triggered when the detector is occupied for more than 3 seconds. So in this case, you can see we use route choice method static. And the relative flow is the value we update with Visvap. It is very important that the number for the routing decision when you use Visvap has to be different, or has to be the only routing decision with that number. So any routing decision you have needs to have its own number. It can't be the same number as another one. So you can't have static routing, static vehicle routing decision 1, 2, 3, 4. If you want to use Visvap, you need to make sure that there is no other routing decision, either partial or anything, that shares the same. So this one has to be 11 or 12 or anything else but 1, 2, 3, and 4. Because in Visvap, when you define a new relative flow to a routing decision. As you can see in the Visvap name, it just says set route. It doesn't say set partial route, static route, parking route, or whatever. It just said set route. So, and that number identifies it. So just imagine it that way, that you say set route, and then basically you say a number here, and Vissim will start looking through all your routing decisions, all kinds of routing decisions you have. And once it's find that, then it will change. So if you have a partial and a static with the same number, then you will have problems. So when you use this with Visvap, you need to make sure that these are not these numbers are not used in any other routing decision. Okay. Then you use the number of the route. So as you can see here, this path or this route it belongs to vehicle routing decision 11, but the path number is 1, or route number is 1. Because the decision number is this, so this is the decision, the pink, and the paths are the blue ones, or routes. And with Visvap, we need to change that. So in Visvap, you say set route underscore set route. 11 is the number of the decision, the pink. 1 is the number of the blue, the route or the path. And the third number is the new relative flow you want. So what we do here, when occupancy is over 3, so that means when the queue reaches the end, then we need to trigger the new route, and that we need to set basically for all 4s, because we have school traffic can come from 2-way. So we have 11, 12, and within 11 and within 12 we have 2 routes. So route 1 is the short, route 2 is the long. So 1 is the short, 2 is the long, and it is the same. 1 is short, 1 is long. So now what we do is the ones, so the short ones from 11 and 12, the short ones go to 0, and the long ones, the 2s, go to 1. So that means all short routes has relative flow of 0, all long routes have relative flow of 1. It not necessarily needs to be 1, it can be 10, 100, 10 million, it doesn't matter. Because if 1 is 0 and you only have 2, if the other one is more than 0, then all vehicles will use that. Okay. Then we have, and if once these are done, then the logic goes to stop, or to the end, sorry. In the next time the Visvap is called, then it checks again for occupancy. And if in that case there is no occupancy there, so there is no vehicle driving on these detectors, and there is no vehicle standing on the end of queue detector, then these lines will be executed. So the ones get 1 for relative flow, and the 2s get 0s. So all the long ones have 0s, all the short ones have 1. So vehicles will go back to the original one. Or when you start your model, it will be true for a long time, this one, this way, so the logic will go this way, instead of going this way, like that. So if I run it, if you look at here, you can see that the relative flow is 1 and 0. If I run it, when the next vehicle comes in, it will probably start blocking it, and now it goes one to the long one immediately. And now vehicles will start going into the long one and accessing it through there. I think it is very easy. The only thing you need to pay attention, and as you can see, this priority rule has a check here. So if there is a vehicle up here, so in this case, for example, this waits until there is enough space. Now there is enough space, so it will get in here to ensure that it doesn't block the intersection back. So it is very nice. And now just arrives, and that's it. And no more will come. And the only thing you need to be aware of is that the routing decision numbers need to be, there can't be an identical one between different route types. And you also need to create a poor file, an empty poor file with the basics, just to define a single group, signal group, a stage one, a red nothing, starting stage one, and that's it. In the signal controller as well, if you see, I created a dummy signal group, but you don't need to place a signal head or anything, just create a dummy signal group. Copy this into your poor file. And that's it, basically. You don't need to do anything else. And also, one more thing, very important, that all detectors should only be activated by school vehicle types. So untick it up here and only tick school or the vehicle that you want to trigger your school. If you select all your detectors on the left side, you can just untick it and just select vehicle class here in the quick queue. If you don't see this, you just click on the wrench icon and you can select your vehicle class. There, not there, but vehicle classes. And there you are. So I hope you found it helpful and useful. Please let me know if you have any questions, and I just want to say a quick thank you if you like or comment to my videos. It really helps with the algorithm. And if you want to support me more, just make sure that you head to my Patreon, or in YouTube you can sign up as a member and pledge a few dollars a month. Thanks for watching, and see you in the next one.